Hello engineers, welcome to Mechanical Training World channel. Today we will discuss about UG-41, that is strength of reinforcement. Before going to the topic, if you are new to my channel, please subscribe and click on the bell icon. You will get notified if I upload any new videos guys. Let's get into the topic guys. If you open the UG-41, the code talks about material strength requirement guys. So the reinforcement material should have an allowable stress value equal to or greater than the visual wall material. What does it mean? So whatever the material you choose for reinforcement, that material has allowable stress value greater than or equal to the visual wall material. So here you can see the allowable value for reinforcement is greater than or equal to allowable value for visual. So we need to satisfy this condition guys. So why we need to satisfy this condition? Why reinforcement material is stronger than the visual wall material guys? Because the reinforcement is meant to restore strength lost due to the opening. If the reinforcement is weaker, it won't compensate properly. So that's why we need to select high strength material for reinforcement. I hope you got this point. So let's go to the next point. When will we use low strength material for reinforcement? Can we use a low strength material for reinforcement, guys? Yes, we can use low strength material for reinforcement than the visual wall. But when we use this, if you cannot get the same or stronger material, you can use a weaker material for reinforcement, guys. But you need to increase the reinforcement area. So whatever the reinforcement area you calculated as per UG-37, that reinforcement area need to be increased. Here you got one doubt, right? How much area we need to increase? How much area we need to increase? For that, I have one formula. Area required, new area required is equal to area required as per UG-37 into ratio of allowable strength of vessel divided by allowable strength of reinforcement. This is the area new area formula for low strength material if you use for reinforcement. So for better understanding, so here you can see one example. So if your visual wall material is SA516 grade 70, then S is equal to 20,000 psi. And if your reinforcement pad material is SA285, then S is equal to 50,000 psi. So this is the low strength material we choose here, right? So if we calculate ratio, this S vessel by S reinforcement ratio, we will get 1.33 as answer. That means we need to increase reinforcement area by 33%. I hope you are getting the point. So what if I have high strength material for reinforcement? Shall we need to decrease the area? No, guys. If the reinforcement material is stronger than the visual wall, you cannot reduce the reinforcement area because the code is conservative. It only considers area, not extra strength. So keep this point in mind, guys. Before going to the next point, if anyone new to my channel, if you like the content, please subscribe and hit the like button. And also share to your friends. They will also get benefited. So let's move to the next point. So UG-41B. So if you open the code book, UG-41B deals with the strength of attachment wheels, which joins visual wall and the reinforcement pad. Yes, so this is the weld which joins visual wall and reinforcement pad. Sometimes two reinforcement pads are joined by welding itself. Okay. So if you follow UG-41, we can ensure welds are strong enough to transfer the required loads. So let's see how we can ensure this point. So the weld strength must be at least equal to smaller of the 3 points, guys. So UG-41B gives 3 points for us to satisfy this condition. So the first point is strength of the reinforcement element itself. The weld should be strong enough so that the reinforcement piece will fail before the weld does. The weld, whatever the weld material you choose for welding these two parts, that must be higher strength than the reinforcement material. So this is the first point. For example, if you have your reinforcement pad, the weld must be stronger than this reinforcement pad, guys. So this is what I want to say. So here you can see W11, W22, W33. So related with weld load strength for the different parts. Here you have some different part sites, 1, 3, 2, right? So these are the weld load for strength parts. So you can calculate by using these formulas, guys. So let's go to next point. That is second point is strength of the required reinforcement area minus what's already in the shell. So I already explained about this point in the UG-37, guys. So what UG-37 defines? So UG-37 defines the required reinforcement area for the opening. Some of this area is already provided by the shell, right? So the weld must be strong enough to transfer the remaining required area. So you can calculate l- total weld load by using this W formula here. And the third point is for weld attachments, see UW15 for exemptions. So what UW15 gives? UW15 gives cases where you don't need to calculate weld strength. So if your design falls under these exemptions, you can skip the detailed strength check, guys. So if you satisfy this UW15, no need to calculate this weld strength formulas, which we saw in before slides. So if it does not satisfy this condition, then we need to satisfy above two conditions. That means the weld strength must be at least strong as the weakest of the above 2 points. By these 3 points, we can ensure weld is never a weak point in the load path. So this is all about UG41, guys. So after this session, please refer to the code book. You will get some more new points there. Thank you, guys.